Okay, let's start an overview of the Tor project. The onion routing project, or simply Tor, is employing the third generation of the onion routing technique in order to provide anonymous surfing and communication. The onion routing technique was developed in the mid-90s by the U.S. Naval Research Laboratory and the Defense Advanced Research Project Agency, to provide safe communication between operatives in the field and intelligence gathering by anonymizing TCP-based applications. In 2002, the Naval Laboratory released the source code of Tor, and the Electronic Frontier Foundation undertook Tor's founding, becoming the cornerstone for the creation of the Tor project organization responsible for maintaining, upgrading, and shaping Tor network as it is nowadays. How does the transmission of data work? Data transmitted using the onion routing is encapsulated in multiple layers of encryption, resembling the layers of an onion. The number of layers is equal to the number of users acting as nodes, also known as relays. This technique assists the user to remain anonymous and evade eavesdropping and traffic analysis techniques which could reveal the origin, destination, and content of a message. Tor users have to decide whether they will participate in the network as nodes or nodes. Thus, it is in volunteer basis. As the first generation of onion routing technique, Tor is anonymizing TCP packets, while offering significant improvements in comparison with the first generation, such as perfect forward secrecy, separation of protocol cleaning from anonymity. Many TCP streams can share one circuit, leaky pipe circuit topology, congestion control, directory servers, variable exit policies, end-to-end integrity checking, rendezvous points, and hidden services. Tor consists mainly of the Tor browser, which offers the appropriate setting in order to connect to the Tor network and the hidden servicing sites hosted in the Tor network. Furthermore, Tor network consists of the Tor nodes and the directory servers, while the nodes share part of their bandwidth, meaning that it will increase or decrease based on the number of the nodes. Thus, the higher the number of nodes in Tor, the faster it will be. Tor nodes or relays are created by users offering their computers purely on a volunteer basis in order to be used as a node. It is highly important to explain that the higher number of nodes means higher available bandwidth, increased robustness of the network against attacks, and making it more difficult to analyze the traffic. Tor consists of three types of nodes based on the guard entry node. The guard node is the first node each user will hop to in order to connect to the Tor network and to the requested service or site. The selection of the guard nodes is done at the user level, and the selection is random in order to minimize the chances of eavesdropping. Then we have the middle or internal node. Middle nodes are the nodes that exist between the guard node and the exit node. Exit nodes are the last nodes before a user reaches the requested destination, and thus this type of node is responsible for sending the request either out of the Tor network or to a hidden service. Let's talk about the bridge node. The main difference with the aforementioned nodes is that bridges are not listed in the main Tor directory authority. Thus, it will be difficult for ISPs to block Tor traffic passing through these bridges. At the moment of recording this video, Tor has more than 1,500 IPv4 bridges and around 250 IPv6 bridges. The Tor directory authorities, which are 10 at present, are databases which contain information and the list of all the active nodes at the network. Thus, they have complete knowledge and view of the network's topology. Information relevant to the router stored in the directory authorities is encrypted with digital signature. To further secure both the directory authorities as well as the entire Tor network, the administrator of each server will process and approve information regarding nodes in order to be published to users. In order for a user to connect to the Tor network, the user's Tor client will have to communicate with the Tor directory authority, holding a list of all the available Tor nodes. Once the user receives this list, the client will randomly decide the path of nodes that will be used in order to reach the destination server, which in turn publishes the hidden service the person is looking for. Each node has knowledge only for the previous and next node, one-hop knowledge of the network, exchanging a different encryption key each time. This method ensures that even if one node is compromised, it will not be able to identify the entire path of the Tor network. In order for a route or circuit to be formed, the Tor browser will download the current list of registered nodes from the directory authorities, and it will randomly select a guard node. Then it will select the rest of the nodes based on their bandwidth and stability. Highest bandwidth and only stable nodes are selected. By default, when 3 nodes are selected, the circuit is formed, and the generation of encryption keys follows.